All right, so let's solve this challenge. The key to this one is realizing that because stacks are LIFO, meaning last in, first out, and queues are FIFO, meaning first in, first out, if we add everything to our queue, then the queue will contain the original string, and if we push everything onto our stack, then our stack will contain the original string. Of course, we'll remove punctuation and spaces as we do this. And so once we filled our queue and we filled our stack, then all we have to do is loop through the stack, let's say, and we'll pop each character off the stack and compare it against the top element in the queue. And because the queue will return the characters reading from left to right, and the stack will pop the characters in the order of right to left, we just have to, on each iteration, pull the first item off the queue, the item that's at the head of the queue, and pop the top character on the stack and compare them. And if they're equal, then we're good. If on one of the iterations we pull the head element off the queue and we pop the top character off the stack and they're not equal, that means we don't have a palindrome. And so, for example, if we just look at the word dad, and so let's say we have a stack and we push D, and then we push A, and then we push D. And so our stack is going to end up having DAD on it. And then this is driving IntelliJ nuts because it doesn't know what I'm doing here because of the all the syntax errors. So with the queue, we'd add D, and then add A, and then add D, and so our queue is going to contain DAD. But the key here is when we pop these items from the stack, we're actually popping them in reverse order. So in the queue, this D is the first D. So when we pull the first item off the queue, we're going to get this D. But when we pop from the stack, we're going to get this D. And so because of LIFO behavior, the characters will be popped from the stack in reverse order. And because of FIFO behavior, the characters will be pulled from the queue in forward order. And so what we're going to do is do a loop, and each time, each iteration of the loop, we'll pull one character off the queue and pop one character off the stack. And so for the queue, we're basically reading left to right. And for the stack, we're reading right to left. And so if we pull off the first character from the queue, we'll get this D, and then we'll pop the top character from the stack, and we'll get the last D. This would be our first iteration, and we compare them, and they equal each other. And so that means that so far our string is reading in the same order from left to right as it is from right to left. And so far we have a palindrome. And then when we pop the next item off the stack, we'll get A, and we'll pull off the queue and we'll get A. We'll compare them. So far, so good. And then finally, we'll pull the last D off the queue and we'll pop the top item on the stack, which at this point would be the first D, and they compare equal, and we're done. And so because all the characters compared equal, we have a palindrome. On the other hand, if we had, I don't know, let's put DADE, basically we have this situation, but we're going to be, when we pop, we're pulling items from the end. And so on the very first iteration, we're going to realize this isn't a palindrome because we're going to pull D off the queue because we're reading from left to right, and then reading right to left, the first item we pop will be E because that was the last one we pushed, and we're going to compare D against E, and oops, they're not equal, so this is not a palindrome. So the key is just to realize that if we loop through the original string, and as we go we push items onto the stack and we add items to the queue, because one is LIFO and the other one is FIFO, if we then loop through again, and on each iteration we pop one item from the stack and remove one item from the queue is basically reading the string from left to right, and the stack is reading the string from right to left. And so if the string reads the same from left to right as it does from right to left, then on each iteration, the character we pop from the stack and the character we pull off the queue should equal each other. And if they don't, then we don't have a palindrome. And so with that in mind, let's go ahead and implement the solution. So once again, I'm going to use a linked list, and I'm going to use a linked list for both the stack and the queue. So I'm going to say character stack equals new linked list. And so that's our stack, and I'm going to say linked list character, and this will be my queue, equals new linked list character. And I'm going to lowercase the string, so I don't have to worry about doing that when I'm pushing and adding to the queue. So I'll say string lowercase equals string dot to lowercase. Okay, so now I'm going to loop around, and on each iteration I'm going to do the same thing I did in the stacks challenge. I'm going to check whether the character is between lowercase a and lowercase z inclusive, and if it is, I'm going to push it onto the stack and add it to the queue. So I'm going to say for int I equals 0, I less than lowercase dot length, I plus plus. I'm going to get char c equals lowercase dot char at I if c greater than or equal to a and c is less than or equal to z, then I'm interested in this character. So I'm going to add it to the queue, and I'm going to add it as the last. I could just say add, but because this is a queue, I'll use add last. And I'm going to push it onto the stack. So stack.push c. And so when we drop out of this loop, I've removed punctuation, I've removed any spaces, any white space. I've pushed all the characters between A and Z onto the stack, and I've added all the characters between A and Z onto the queue. And so now we need another loop. And what we're going to do in this loop is just iterate through the stack until it's empty. And on each iteration, we're going to pop one character from the stack, and we're going to remove one character from the queue, and we're going to compare them. And the stack will be effectively reading the string from right to left, and the queue will effectively be reading the string from left to right. And so if on each iteration the character that we pop and the character that we remove from the queue are equal, then we still might have a palindrome. If we hit an instance where the character we pop from the stack is not equal to the character we pull from the queue, then we do not have a palindrome. And so I'm going to say while not stack.isEmpty if not stack.pop dot equals queue.remove first, then we don't have a palindrome. Otherwise, if we make it out of the loop without returning, then every character we pop from the stack equaled the character we remove from the queue. And so in that case, we have a palindrome, and so we'll return true. And it's a shorter and more elegant solution than the one we did in the stacks challenge, but we hadn't learned queues yet in the stacks challenge, and so that solution involved a little more manual work, I would say. Now that we know queues, we have the more elegant solution. And if you were asked to check for a palindrome and they didn't tell you how to do it, or they just said use a stack or something, this is a more elegant solution. So once again, we should get true, 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 false, and true. So let's give this a try. And we do. We get true, 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 false, and true. So that's it for queues. I'll see you in the next section.